Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your younger brothers and sisters, and to your friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies as part of your preparations to engineering life, then please don't forget to subscribe. Level 135, the product of inertia of the shaded area is with respect to the xy and x prime y prime axis are 8 times 10 to the 6 mm to the fourth and negative 42 times 10 to the negative 6 mm to the fourth respectively. Compute the area of the figure whose centroid is C. So our guide formula Ixy equals moment of inertia with respect to the centroid, product of inertia with respect to the centroid I bar xy plus area bar x bar y. So Ixy equals I bar xy plus area bar x bar y. So Ixy is 8 times 10 to the 6, then I bar xy unknown with respect to the centroid, then area is also unknown. Bar x is positive 30, while bar y is positive 20. So 8 times 10 to the 6 equals I bar xy plus area unknown, bar x positive 30, bar y 20. Call that equation 1. And with respect to the x prime, y prime axis, this point is located positive 50 plus 30 to the right, and this point is 60 minus 20, 40 mm below, so it's negative 40 for bar y prime. So Ix prime y prime equals I bar xy area bar x prime bar y prime. So negative 42 times 10 to the 6 equals I bar x y plus area unknown, positive 80 as I said, 50 plus 30, then negative 40, this is 40, C is 40 mm below the x prime axis, so that's why it's negative 40. To eliminate I bar xy, then we have to subtract equation 2 from equation 1. That is 8 times 10 to the 6 minus negative 42 times 10 to the 6. I bar xy will be eliminated. Then equals area times quantity 30 times 20 minus 80 times negative 40 or plus 80 times negative 40. So 8 minus negative 42 times 10 to the 6 equals A quantity 30 times 20 minus negative, because this is negative, so just make it positive here. So we can now solve for the area, and area is equal to 13158 mm square. Level 137, compute I bar xy and Ixy for the plane region. So the region is symmetric with respect to this axis here. So the answer for I bar xy is 0, because remember the principle, if the area has at least one axis of symmetry, then the centroidal product of inertia is 0. But I'll present two solutions here to prove that I bar xy is really 0. So for Ixy, we have to apply transfer formula. Then let's have a rectangle, then quarters, semicircle, then minus circle. And with respect to the centroid of each, the product of inertia is 0. So only the area bar x bar y component of the formula will have a value. So for rectangle, that's xg, and yg lies on this axis of symmetry. So this is our guide formula. Take note that for each area, I bar xy is 0, so only this part will have value. For the rectangle, barred x is area is 18 by 12, 6 times 2. Barred x is 9 and barred y is 6 for the rectangle, that is 6. For the semicircle, area is pi 6 square over 2. Barred x is 18 plus this distance is 4 times 6 over 3 pi, 4 times r over 3 pi. Remember, barred y is 6. And for the circle, area is pi 4 square over 2, but we have to subtract it. Then barred x is 18, barred y is 6. So Ixy for the rectangle is 0 plus area 18 times 12, barred x is 9, barred y is 6. Then plus this semicircle, I barred xy 0, then plus area pi times 6 square over 2. Barred x is 18 plus 4r for 6 over 3 pi. Barred y is 6. Then for semicircle minus 0, then plus pi 4 square over pi 4 square. Barred x is 18, barred y is 6. So computing, Ixy equals the first one 11664, the second one 6971.26, and for the circle minus 5428.67. Combining Ixy therefore is 13207 inches to the fourth. Then for I bar xy it is 0 because this axis is an axis of symmetry of all composite areas. But I'll have another solution showing that this is really the answer. So Ixy also is I bar xy plus area barred x barred y. Then let's locate the centroid of the entire region. Area is rectangle 18 times 12, for semicircle pi 6 square over 2, for circle pi minus pi 4 square. So that would be 216 plus 18 pi minus 16 pi, or in short 216 plus 2 pi. Then by Varignon's theorem, quantity 216 plus 2 pi xg equals 216 times 9 for the rectangle, area 216, then barred x 9 for the semicircle, plus 18 pi times quantity 18 plus 4r, 4 times 6 over 3 pi, or this is 8 over pi, plus 18 pi, 18 plus 8 over pi, then minus semicircle 16 pi, then times 18. So solving for xg is 9.9022 inches. YG, there's no need to solve for YG because it is 6, because this is an axis of symmetry. Then IXY is 13206.6, more accurate value of this because this is rounded off, equals centroidal product of inertia, IGXY or I barred XY, plus area of the region. This is the value of barred X, and this is the value of barred Y for the region, which is 6. So subtracting this value from here, we expect that IGXY is 0, or I barred XY is 0. So that's it. That really proves that when the region has an axis of symmetry, product of inertia with respect to the centroidal axis is 0. Level 138, determine I barred XY for the plane region shown. So let's just treat it as rectangle less parabola, and I'll present another two solutions here. The alternate solution is the simpler one. So for the parabola, remember from previous problem that we derived the product of inertia of this parabola with respect to the xy axis and with respect to the centroidal axis. And if you can recall, it was with respect to the xy axis b square h square over 6, and with with respect to the centroidal axis, b square h square over 60, and that is from level 108. Level 108. Then the location of the centroid, because this parabola is open upward, just like that, that is 3/8 of b, and this is 3/5 of h. That's 3/5 of h. Okay. So here, this is the parabola which measures 12 inches by 18 minus 6 is also 12. The area of parabola, by the way, is 2/3 base times height. So that's the location of the centroid. This is 3/8 of 12, so that is 4.5 inches. While this distance is 3/8 of 5, 3/8 over 5.6 of 12, 7.2 inches, but with respect to the x-axis, 6 plus 7.2. So area is 12 by 18 for the rectangle minus parabola 2/3 of 12 times 12. So area is 216 for the rectangle, 96 for the parabola, so 120 for the entire region. Then by Varignon's theorem, that's g, x, g, and yg distance. So area 120 times xg equals 216 for the rectangle, then x of the rectangle is 6 half of 12, then minus 96 times 4.5 for the parabola. So xg equals 7.2 inches. 120 times yg equals 216 times 9 for the rectangle, half of 18 is 9. Then for the parabola, minus 96, then as I said, 6 plus 7.2, so 13.2 inches. So yg therefore is 5.64 inches. Then we transfer. So I barred xy equals ig xy. This is for the rectangle with respect to the centroid 0. The area of rectangle is 216. Xg, to make it consistent for the entire region, is 7.2. Then the x of the parabola is 6. So minus 6. Then y times yg for the parabola for the entire region, then this distance, this is treated as the distance barred y, which is 5.64 minus 13.2 to make it consistent. So this is xg of the entire region, yg of the entire region, then the individual x and y for the area. So that's for the rectangle. For the parabola, minus area of parabola minus with respect to the centroid, b square h square over 60, or 12 square over 60, then plus area parabola 96, then xg of the entire area 7.2, x of the parabola 4.5 minus, then yg of the entire area 5.64, then the yg of the parabola is 6 plus 7.2, so minus 13.2. So computing I barred xy equals ig xy, the first term is negative 870.912, then for this second term, positive 1613.952. So combining, so I barred xy equals 743 inches to the fourth. So let's have we have the simpler solution. So because barred x and barred y have been found, so let's just compute ixy for the rectangle, then less ixy or the parabola. Then having found ixy, then let's equate it to I barred xy plus area of the entire region, which is already computed, 120, barred x of the entire region, or xd 7.2, barred y of the entire region 5.64. So ixy is equal to I barred xy equals for For the rectangle, this is our guide. With respect to the centroid 0, area 216, barred x of rectangle 6, barred y 9. So for the rectangle 6, then 9. Then minus for the parabola, which is b square h square over 6, 12 square, 12 square over 6, area 96, barred x of parabola 4.5, barred y 13.2. So ixy equals 11664 for the rectangle, then minus 6048 for the parabola. So 5616. We equate 5616 to I barred xy, then plus area 120, barred x 5.64, barred y, barred x 7.2, barred y 5.64. So I barred xy is equal to 743.0 inches to fourth, which is simpler. But this first solution here, though longer, but it can develop your patience and analysis also. Level 139, use numerical integration to compute the product of inertia of the region shown with respect to the x and y axis. Also apply another appropriate method. So this is first by Simpson's one-third rule. So product of inertia, integral of ixy dA. So that's our strip x horizontal, then thickness dy. So dA is x dy, and x is not really x, it is x over 2, location of centroid of the strip from the y-axis, while y is simply y. So ixy equals integral of xy dA, where x is x coordinate of the element, which is x over 2, y is just y, and dA is x dy from the figure. So x over 2, y times x dy. So ixy equals 1/2 integral of x square y dy. Then if we apply Simpson's one-third rule, this dy here is delta y, and the h, ho, h1, h2, and so on would be this x square y term. And Simpson's one-third rule is d over 3 quantity ho plus 4 times summation of h add plus 2 times summation of h even plus h sub n. So area, or ixy in this case by Simpson's one-third rule, is 1/2, and this part here by Simpson's one-third rule is delta y over 3 quantity ho plus 4 summation of h add plus 2 summation of h even plus hn. But take note that ho is this value, which is x square y. So let's begin with this part, call that o, where x is 406. So 406 square, its y is 185, 185, so 370 below the x-axis, so that's negative 370. This is the first h1. X is 420, so 420 square, its y is negative 185. It is 185 below the x-axis. Then next is 2, h2. X is 392, but 392 square, but its y is 0. It is on the x-axis. 338 square, y is positive 185. 4 is 218 square, y is 370 rather. So ixy equals 185 over 6, 2 times 3 is 6, quantity 406 square times negative 370 plus 4 times h add 420 square, negative 185, plus 338 square, positive 185. So I hope you understood that this is for summation of h add 1 and 3 are add. Then for even, this is only the considered even part because this is hn here. So 2 times 392 square, but y is 0. 2 times 392 square times y, which is 0, plus hn 218 square, hy is positive 370, 185 times 2. So computing ixy equals negative 2.757 times 10 to the 9 mm to the fourth. And here is my another approximation. We treat each as rectangular areas. So the average here is 406 plus 420. The average x is 413. And the area is treating this as a rectangle. 413 times 185 is 76405. For the next median line, 420 plus 392 divided by 2. The average length is 406. And the area is 406 times 185, 75110. Here, 392 plus 338, 365, that's the average. Then the area, 365 times 185, 675.25. And lastly, 218,338 over 2 is 278 times 185. The area is 51430. Then I'll use I xy equals I barred xy plus area barred x barred y. The I barred xy or the centroidal product of inertia is 0 because we treat each as rectangle, and the centroidal product of inertia of rectangle is 0. So only the area barred x barred y component will have value. Barred x will all be positive, but there are barred y which are negative. So 180, for instance, for this area here, 185 plus half of 185, that's negative 185, and negative 92.5, that's 270, 92.5, 277.5, negative 277.5, I think. So area barred x barred y will be left. So IXY equals area 176,405 barred x 413 over 2, half of that length. Barred y is below the x-axis, so negative 185 and negative 185 over 2, negative 170, negative 277.5. Next, plus 75,110 times x bar is 406 over 2. Barred y is negative 185 over 2 or negative 92.5. So 75,110, 406 over 2, negative 92.5. For the next area, 67525, barred x is 365 over 2, barred y is 92.5 positive or 185 over 2. Then lastly, plus 51430, barred x is 278 over 2, barred y is positive 277.5. So computing for IXY is negative 2.665 times 10 to the 6 mm to the fourth. This is the other approximate way, and this is my style. If you want to make it closer to that value, then we may have intermediate areas region. So for example, 406 plus 413 divided by 2, let's introduce another line here, another line. So the number of partitioning would be increased to make it close to that. But for these values, they are already close. Just to make it more accurate, I suggest you add more lines, then recompute. But the idea, that's enough. Level 140, the last problem in this batch of problems. Determine the dimension B of the square cut out so that IXY is 0 for the region. So here's the given figure, then we treat this as IXY of the rectangle, which is 0, minus IXY of the, it is 0 because the X and Y axis coincide with its centroid. So with respect to the centroid 0, then the area barred x barred y component of this rectangle is also 0. That's why. Then minus for the square, or for the square, the area, with respect to the centroid 0, then plus area b squared barred x is negative b over 2. Negative b over 2, barred y is positive b over 2. And for this triangle in this orientation, we have to locate the centroid. Its product of inertia in this orientation is with respect to the centroid is negative b square h square over 72. Then area is 1 half 45, 45. Barred x is this distance, which is negative. Barred y is this distance, which is also negative. And the location of the centroid for our solution there. This is 1/3 of 45, so 15. 1/3 of 45 from the base, 15. Therefore, barred x is from distance from the y-axis, it is to the left, so negative 45. Barred y is also negative. 60 minus 15 is 45, so negative 45. So ixy equals it is 0, and for the rectangle it is also 0. Then minus for the square with respect to the centroid 0. Area of square b square. Barred x is negative b over 2. Barred y is positive b over 2. Then minus for this cutout triangle with respect to the centroid 45, negative 45 square, 45 square over 72, plus area 1 half of 45, 45, so 45 square over 2. Barred x is negative 45, barred y is negative 45, as mentioned earlier. So negative of negative is positive b to the 4th over 4, and this is negative 1993359.375. Then times 4 to the left, times 4, it becomes positive, then 4 to, so we can now solve for b. B is 153.14 mm.